Here we are given a feed rate of 4,000 kg per hour entering a liquid countercurrent liquid extraction system, and the feed rate has a concentration of 0.15, and it must produce 3,489 kg per hour here. Then fresh solvent is allowed to enter the system, which has a concentration of YB is equal to 0.1233, and the extract rate must have the concentration of 0.4. Now we are also given distribution coefficient as 5.5. We are required to find the number of plates or the number of stages required in the system. We are also required to have the rate of the entering fresh solvent, and we are also required to get the percentage recovery of the solvent. Okay, so first we have to find the rate or the pure diluent rate by multiplying the given rate in LA, which is 4,000, times 1 minus the concentration of the entering feed, which is 0.15. Computing, we can get L prime is equal to 3,400 kg per hour. Next would be, we have to find the concentrations, which are the solute per solvent and the solute per diluent concentrations. So here we have to use the overall solute balance, which is L prime times capital XA plus V prime times capital YB equal to L prime times capital XB plus V prime times capital YA. So by separating L prime over V prime, we can get YA minus YB over XA minus XB. So we have this equation. Now, getting capital YB, we have to compute for it. So it is computed by 0.1233 minus 0.1233 is equal to 1233 over 8767 using the calculator. Next would be YA. We are also given the concentration of the extract, which is 0.4. So it is computed by 0.4 over 1 minus 0.4 is equal to 2 over 3, or 2/3. Next would be XA. We have to compute XA. We are also given the concentration of the entering feed, which is 0.15. So we can compute for this by calculating it. 0.15 over 1 minus 0.15 is equal to 3 over 17. And we have no XB. So we can't find V prime because we have another unknown, which is XB. So how can we find V prime? So we have to equate the following. We have to find a relation of VB and V prime. So the relation here is VB times the small yb is equal to V prime times the capital YB. And also we can also use VA times small ya is equal to LA times small ya is equal to L prime times capital XA. But we don't have to use that. Instead, we have to use the solvent rates. So it is VB times small yb is equal to V prime times capital YB. Also, VA times small ya is equal to V prime times capital YA. So by separating V prime and VA and equating VA and VB, we can get VB times YB over capital YB is equal to VA times small ya over capital YA. How did we get that? So we equated V prime, then we got VB small yb over capital YB is equal to VA YA over YA. So by computing it, we can get this expression. VB is equal to 0.4 over 2 over 3 by substituting everything over 0.1233 over 1233 over 8767 times VA. So using OMB, which is LA plus VB is equal to LB plus VA. So substituting the values that we have, which is 4,000 as the entering feed, plus VB, which we have to use the expression that we have later, is equal to 3489 plus VA. So we simplified this expression to this expression, so we can substitute VB to this expression. So we have the OMB as 4,000 plus 0.6844 VA is equal to 3489 plus VA. So we have the value of VA here by computing or using ShipSolve. Then we can get VB by using the expression here, which is 0.6844 times VA. We have VA, so we can get VB. Now we have to find the pure solvent rate, which is the relation that we had a while ago, which is V prime times capital YA is equal to VA small ya. So V prime times 2/3, which is the value of capital YA, right, is equal to the value of VA, which is 1619.13815 times 0.4. So by ShipSolve, or separating 2/3 from V prime, we can get V prime as 97.48289 kg per hour. Now we have all the values that we need. We can find XB by substituting V prime in the equation that we have a while ago, which is 3400 over V prime is equal to YA minus YB over XA minus XB. Why do we need to find XB? So we can find the values of YA star and XB star. No, it's just XB star or YB star for the Kremser equation. So substituting V prime would be 3400 times XA minus XB over YA minus YB is equal to V prime. So by ShipSolve, we have the value of V prime. We can get the value of capital XB, which is 0.026169. Now we can compute YB star by using the distribution coefficient, which is 5.5 times the value of XB to get the YB star, or the equilibrium. So YB star, by computing, we can get 0.1439295 as the value of YB star. We also need the value of YA star, which we can get already, which is 5.5 times the value of capital XA, which is 3 over 17. We can get 33 over 34. Now we can get the number of stages by using the Kremser equation, ln yb minus yb star over ya minus ya star all over ln a, which is L prime over mv prime. So substituting everything, we can get ln times the value of yb, which is 1233 over 8767, minus 0.14392, which is the value of yb star here, over ya, capital Ya, which is 2/3, minus the value of ya star, which is 33 over 34, which is here, all over ln L prime, which is this 3400, over 5.5 as the distribution coefficient, times v prime, which is 971.4829. So calculating the number of stages, calculating everything, we can get 10.013 stages, or we can simply use 10 stages. Now for the percent recovery of, it's the percent recovery of the fresh solvent. In the fresh solvent, we can use the formula. Percent R is equal to 971.48289, which is the value of the pure solvent rate, times 2/3, which is the value of capital Ya, all over 3400, which is L prime, times 3 over 17, which is capital Xa, plus V prime again, then this is YB. So calculating, we can get the percent recovery, which is 87.9213%. And that's all for liquid extraction, quiz number 3, number 1. Thank you and God bless.